Welcome to week 2 of the AMC8 Advanced class. I'll now be explaining the solutions for the fun problem of the day. So, for this fun problem of the day, the difference in let the table have a height of x centimeters, and let the sleeping cat have a height of a centimeters, and the standing cat have a height of b centimeters. Then we have that b, come on, b minus a plus x equals 150 from this situation. From this situation, we have that a minus b plus x equals 110. When you add these two equations up, equations 1 and 2 up, this tells you that 2x equals 260, or x equals 130, and that's the height of the table. Now, for the second problem of the day, let the adult ticket cost $8 and let the student ticket cost S dollars. The fact that 3 student tickets and 2 adult tickets cost $34 says that 2A plus 3S equals 34. We're also given that S equals 3/4 of A, which also means that A equals 4/3 S. When you plug this in, you get that 3 plus 4 over 3 times S equals 34. This fraction is just, sorry. When you plug this in, you get that 8/3 A plus 3, 8/3 S plus 3S equals 34. And so this simplifies to 17 over 3S, which tells you that S equals $6. Okay, so everyone did a good job on the homework. One note is that your answers should not come with units. And it's because when you get to higher up competitions, such as the AMI, short answer doesn't have any units. Their answers have no units. Now, some people had difficulty with number 4 of the homework, so I'll go over that now. Okay. So when we can combine the fact that Andrea is 29 older than Jim, we can work backwards to the starts. given that Andrea is 29 years older than Jim. So, first of all, when the sum of their ages was 47, we have that Jim's age plus 29 plus Jim's age is equal to 47, which simplifies to J equals 9. So, this condition is when Jim was 9 years old. So now Jim is twice that. So in this situation, Jim is 18. Now Andrea is 3 times that age, so she is 54 years old. Andrea's current age is still 29 more than Jim's age, so Andrea's age plus Jim's age is 2 times Andrea's age minus 29, which is 108 minus 29, which is 79. Did everyone understand that? Okay, so we'll be moving on to the second lecture on algebra. We're going to cover travel, work, sequences and patterns, statistics, functions, and polynomials. First of all, travel. When we're working with speed, write everything in terms of the speed. When you're working with time, write everything in terms of the time. When we're working with distance, we write everything in terms of the distance. So the variable that you will represent everything in terms of is usually the variable that you want to find, that the question wants you to find. And to relate speed, time, and distance, we have this equation, which says that the average speed equals the total distance traveled divided by the total time of traveling. So here's your first example. These kinds of problems are easier if you write them down on paper because it's less likely that you will mess up and it's more organized that way. Please send answers to Gordon Chan when you have them privately. Okay, so for this problem, without loss of generality, assume that there are 120 steps in the elevator. When it is not operating, Clea walks down 60 seconds. So she does 2 steps per second. Now, when it is operating, she takes 24 seconds, which means there's a total of 5 steps per second. 2 of these steps are her own, which means that when the elevator is operating, it operates at 3 steps per second. And since there are 120 steps, this means that the escalator will take 40 seconds to ride. Okay, we will now move on to work. So for work, it's rate times time. Work just equals rate times time. Oh, and I got that there were it's just an assumption that there are 120 steps. It's just an example. It doesn't have to be 120 steps. It could be something like 240, 360, but 120 is convenient.
But you didn't like but didn't on the thing on the word problem it didn't.
Uh, okay. I just the 120 steps is just an assumption. It's not necessarily true, but if you replace 120 with x, it turns out that it still holds the same because this is x over this is x over 60, this is x over 24, and x over 60 minus x over 24. Sorry. X over 24 minus x over 60. 1 over this should. Sorry. Anyways, it just makes the numbers a lot simpler. Okay, so make sure to take care that the units for work rate and time match for work rate problems. And there are problems that involve combined work, such as an assistant is doing something and then a few more assistants come along, or sometimes workers are doing something and then a few are fired. Yeah, here's your next example. Okay, I think I'll give a hint. Let the workers be able to paint 1 square foot of fence in 1 hour. You could also set this to be X, but you don't have to. You can just say that it's 1. Okay, looks like people had a hard time with this question. So let's start off with this assumption. It may not necessarily be true, but for the sake of this problem, we can just assume that it's true. So from 8 to 10, the first worker paints 2 square feet. Now from 10 to 11:30, the 3 workers each paint 1.5 square feet. So the fence has an area of 6.5 square feet. Now, on Tuesday, let the first worker paint alone for H hours. Then H times 1 plus 3 times 2.9 minus H, because 8 o'clock to 10:54 is 2.9 hours, equals 6.5. And now 8.7 minus 2h equals 6.5. Solving this gives that h equals 1.1, which equals 66 minutes. So the worker painted alone for 66 minutes. Are there any questions? Also, I'm sorry if there is a lag between what I'm saying and what I'm writing. Okay, I'll move on to sequences and patterns. So, an arithmetic sequence. In an arithmetic sequence, the difference between one term and the next one is constant. In other words, we just add something each time, on and on and on. So this is an example of an arithmetic sequence. The difference between each term is 3. It can be expressed by the equation xn, an, or however you want to call the sequence, equals 3n minus 2. This is what a general arithmetic sequence looks like. It holds true for any a and d. If a is the first term, and d is the difference between each term, each consecutive term, also called the common difference. We also have the rule xn equals a plus d times n minus 1. And we use n minus 1 because d is not used in the first term. So this story of Gauss is something that we went over last week, but it applies very well to arithmetic sequences. Using Gauss sums, we can calculate the sum of some portion of arithmetic sequences. For example, to find the sum of the nth to the nth term, including both terms, we just first find the average of the terms. Since the numbers are in arithmetic sequence, the average is simply just the average of the nth term and the nth term, which is an plus am over 2. Next, we multiply this by the number of terms, which is m minus n plus 1. You have to have the plus 1 here because otherwise you do not account for one of the two endpoints. For example, when we can sanity check this with the n equals 1 case, which gives this, and we already know this. Now, geometric sequences are very similar to arithmetic sequences, except they multiply the previous term by a constant. This is an example of a geometric sequence. And Charles, that's basically what this is. And that only holds when it's 1 to plus 2 plus 3 plus 4, all the way to n. Okay, so this is a geometric sequence. It has a factor of 2 in between each term, meaning you multiply by 2 each time. And the equation is 2 to the n. And in general, this is what a geometric sequence looks like, where a is the first term and r is the is the factor in between each of the terms, also called the common ratio. Note that r should not be 0, because then you get this, which, although could be considered geometric, really isn't very interesting at all. And the rule for the nth term is this. Okay, is this. And once again, it's n minus 1. So here is an example. And here's a quick solution because it's really quite short. The square root of the product of the first and fifth numbers, also the geometric mean, is just the third term. Y, the fifth term, is a times d to the fourth, and the first term is a, and the square root, oh my god, is a, and the square root of a1 times a5 equals square root of a times a d to the fourth equals ad squared, which equals a3. And the third term is already given and equals 121 over 7. In a similar way, the mean of the nth and the mth term if is just their is just the term whose index is their average. Okay, now here's your example. And once again, please send answers to Gordon Chen once you have them. So a quick hint for this problem is just to ignore what the terms actually are and just consider it mod 5. If you don't know what mod 5 is, I think we are going over that in the number theory section. And for now, just know that mod 5 x mod 5 equals the remainder when x is divided by 5. Okay, so continuing off with the mod 5 hints. The first term is 1, 3, 4, 2. And now 4 plus 2 is 6, which is 1 mod 5. 2 plus 1 is 3. 1 plus 3 is 4, and so on. It repeats every 4 terms. And now note that none of these are 0 mod 5. But it must be true that a multiple of 5 is 0 mod 5. So the answer is that there are 0. The answer is that there are 0 multiples of 5 in the whole sequence. It doesn't even matter if the first 100 or not. So now we're going to move on to statistics. So the mean or the average is the sum of the numbers divided by the number of numbers that there are. To calculate it, you just add up all the numbers, then divide by the total number of numbers. So for example, the mean of 2, 7, and 9 is 2 plus 7 plus 9 over the number of numbers, which is 3, and equals 6. So the mean is 6. The median is the middle number when all the numbers are written in increasing order. For an even number of terms, it's the average of the two middle numbers. So take this example. 10, 11, 13, 15, 16, 23, 26. There are 7 numbers here, which means that the median is just the middle term. Now, excluding what the median would be, there are 6 values, 3 on each side of the median. So we can count back from either endpoint to 4. 1, 2, 3, 4. So 15 is the median. And now here is another example of a long list of numbers. And to find the median, you arrange them in increasing order. And there are 15 numbers, so you want the 8th term. And it turns out that this is the 8th term. So it's 23. Another example of numbers is 1, 2, 4, 6, 8, 9. Now there are 6 numbers. So you take the average of the middle 2. And excluding the middle 2, there are 4. So the 2 numbers you want are the 3rd and the 4th numbers, counting either way, which are these 2. And the median is their mean, which is just 5. The mode is the number that appears the most frequently. To find the mode, you can put the numbers in increasing order, like the rest. Then you can count how many of each number there are. So for example, in this list, you can arrange it to form this list. And now it should be clear that most of these numbers only appear once, except for the number 23, which appears a total of 4 times. So the mode is 23. Now, the range is the highest number in the group divided by the smallest number. So for example, in this set, the lowest value is 3 and the highest is 9. The range can be misleading when it comes to trying to find stuff about a set. For example, for this set, the lowest value is 5 and the highest value is 3,616. So the range is 3,611. And now it may seem like there's a wide variety of things here, but in reality, the numbers are all about 10, except for that one 3,616. Now, here's your next example. Okay, it looks like people are having trouble with this question. So, first of all, the sum of the numbers is 110. And when you order them from smallest to largest, the sixth number is 9. Since the unique mode is 8, it must appear at least twice. So you want the first 10 terms to be as small as they can for the largest value of this term. If 8 appears twice, you can get the list 1, 2, 3, 8, 8, 9, 10, 11, 12, 13, which sums to 77. This is for the first 10 terms, excluding the final term for now. Now, if 8 appears 3 times, you can get 1, 1, 8, 8, 8, 9, 9, 10, 10, 11. And this sums to 75, which is smaller. Now, if 8 appears at least 4 times, then the sum of the first 10 numbers will be larger than 4 times 8 plus 5 times 9 equals 77, because the 6th through the 10th terms are at least 9 each. And there will be 4 eighths here. So the smallest possible sum of the first 10 numbers is 75. And so the largest possible value of the 11th number is 110 minus 75, which equals 35. Okay, I'll move on to function and operations. So a function relates an input to an output. It's similar to a machine. And here is an example of a function, and this is its input, and this is the output. We read this as f of x equals x squared. For example, with this function, an input of 4 becomes an output of 16. So f of 4 equals 16. And similarly, f of negative 1 equals 1. For example, these two are both functions. The absolute value is an example of a special function. It's the distance of a value from 0. You could also think of this as a piecewise function, but we don't need to do that. So absolute value of negative 4.5 equals 4.5, and the absolute value of pi equals pi. The fourth function is the greatest integer that's less than or equal to the number. For example, floor of pi equals 3, and floor of negative 3.2 equals negative 4, and floor of negative 3 equals negative 3. The ceiling function is the smallest integer greater than or equal to the number. For example, the ceiling of pi is 4, and the ceiling of negative 19.8 is negative 19, and the ceiling of 5 is 5. The fractional part of a number is the number subtracted by its floor. Equivalently, this equals x minus floor of x. For example, the fractional part of 4.8 equals 0.8, and the fractional part of pi equals pi minus 3. Now, for negative numbers, you cannot just take the part after the decimal. That's not true. The fractional part of negative 3.2 equals 0.8, for example. Now, when working with fractional parts, it's often better to keep the integer and the fractional parts up separate. Here's your next example. Okay, we're probably gonna be a bit rushed of time, so I'll just explain this right now. Actually, I'll give a minute or two. Yes, the ceiling of 19.8 is 20 and is not 19, but the given example was the ceiling of 19, negative 19.8, which equals negative 19, and is not equal to negative 20. I'm sorry if I said that wrong, but that's what I meant. Okay, so f is linear. So you can think of f of x for integer x as arithmetic sequence. So f of x minus, sorry, f of x plus 1 minus f of x equals c for all x. So f of 6 minus f of 2 equals 4c, and is given to be 12. So c equals 3. And now f of 12 minus f of 2 equals 10c equals 30. Okay, on to polynomials. So this is what a polynomial looks like. This one has three terms. The word polynomial comes from the root poly, meaning many, and nomial, which means term in this case, so it means many terms. A polynomial can have constants such as 3, negative 20, or 1 half, variables such as x and y, and exponents such as the 2 and y squared. But you can only have the exponents of 0, 1, 2, 3, 4, etc. These can be combined using addition, subtraction, multiplication, and division. But you cannot divide by a variable. So something like 2 over x is legal. A term of a polynomial is defined as the product of variables and constants. So for example, 29x is a term of a polynomial, and same thing as 29ax squared. Also, polynomials have at least one term, but they do not have an infinite number of terms. Now, the degree of a polynomial is the largest exponent that a variable is raised to in any term of a polynomial. If there are multiple variables, the exponents are added in the degree. A quadratic is a polynomial with only one variable that has a degree of 2. A general quadratic can be expressed as ax squared plus bx plus c. The roots, or zeros of this quadratic, are the x values such that if we plug them into the equation, we just get 0. Another way of writing a general quadratic, ax squared plus bx plus c, is this thing. So to solve for the root of a quadratic, we can set this equal to 0, which gives this equation. And now we can take the square root of both sides and subtract b over 2a from both sides of the resulting equation. So it gives you that x equals negative b plus minus square root of b squared minus 4ac over 2a, which is very important and is known as the quadratic formula. If a is positive, then the minimum of this quadratic occurs when x equals negative b over 2a, and it equals c minus b squared over 4a. Now, if a is negative, the maximum of this quadratic occurs when x equals negative b over 2a to get c minus b squared over 4a. This is what a single variable polynomial looks like. And the sum of the pair of k roots is minus 1 to the power of n times an minus k over an, and the product of the roots is this. And there are also more, but yeah. These formulas are known as Vieta's formulas and are very useful, but I do not expect that you will need them on an AMC8. So here are some formulas for expanding stuff. These two are almost the same thing. And this, and this, and this, and these are all very useful. They're all very useful. For cubes, this is the difference of cubes. This is sum of cubes. This is just expanding a general form. And and we are now on exercises. But yeah. Okay, we'll do this exercise and then I think we can end class there. Please don't leave yet though. Okay, so let T be the amount of time in hours that early bird has to travel to be on time. Now, let the distance be T miles. So, D over 40 plus D over 40 equals T plus 1 over 20, and D over 60 equals T minus 1 over 20. So this simplifies to D equals 40 T plus 2. And this D equals 60 T minus 3. And okay, so you have that 40 T plus 2 equals D, and 60 T minus 3 equals D. Okay, so 40 T plus 2 equals 60 T minus 3. So 20 T equals 5. So T equals 1/4. So now D equals 40 times 1/4 plus 2 equals 12. So T over D equals 12 over 1/4 equals 48 miles per miles per hour. Okay. Okay. That's it for class. The remaining exercises will be homework, and handout and recordings will be posted on Google Classroom later. And let's all thank my assistant, Gordon Chan, for helping me with all the keeping track of answers and stuff. Thank you for attending this class. Bye.